Okay, calculus, we're going to look at some of our laws of limits. And if we know two limits, the limit as x approaches a of f of x plus g of x, all we have to do is find the limit as x goes to a of f of x and add that to the limit as x goes to a of g of x. And it works that way. You can simply separate them out into two limits. Same thing here. Same thing here. If you have a constant, if you're multiplying two together, if you're dividing, just make sure g is not 0. Same thing here. But now I want to talk about this. The limit as x approaches a of a constant. For example, the limit as x approaches, we'll say 5 of a constant, we'll say 2. What that means is you have a function 2. So as x approaches, say 5, you know, what is the height of the function always approaching? It's always approaching 2. So the limit of a constant is always just that constant. Here, what if you have the function x, which is a line just like that? So for example, it contains the point 33. So you can see whatever the input is, the output always is as well. So in that case, the limit will always be a. And when you have polynomials, you can just go ahead and substitute a in, a to the nth, or in this case, the nth root of a. In this case, the nth root of f of a. So let's just use some general ideas involving limits and operations here. It says direct substitution for a polynomial or rational function. In most cases, if you have a nicely behaving function, you can simply plug in a to the function and it will give you the limit. So we're going to look at some algebraic examples. We're also going to look at some graphical examples. We're going to look at some abstract examples. Here it says, given that the limit as x approaches a of f of x is 6, the limit as x approaches a of g of x is -2, and if h of x is 0, find the limit as x approaches a of f of x plus g of x. Well, we just break it up. The limit as x goes to a of f of x plus the limit as x approaches a of g of x. Well, we know that that first one is 6. We know that that second one is -2, so therefore the answer is 4. Very simple, okay? All right, in letter B, this will be 6 divided by 0. And 6 divided by 0 is undefined. We really don't know what that results in. Different than 0 over 0, we can sometimes uncover that, but divided by 0 is an undefined value. Can't divide by 0, so please keep that in mind. For this one, it will be -3 times whatever the limit as x approaches a of g of x is, which is -2. And then we'll add 5 to that. So we get 6 plus 5 is 11. Next one for letter D, we have the square root of. The limit as x approaches a of h of x is 0. For g of x, it's -2. And then for f of x, it's 6. So the square root of 0 plus 6. You can take the square root of 0, it is 0, plus 6 is 6. There you have it. So those should be pretty intuitive for you. Here we look at the graphical examples. Limit as x approaches 1 of f of x times g of x. So we're going to determine the limit as x goes to 1 of f of x. We'll multiply by that as the limit as x approaches 1 of g of x. Let's see what happens here. This one's f of x. We're going to approach 1. Looks like I got 3 and 3, so the answer is 3 for that. And for g of x, I'm going to approach 1. It's like -1 and -1, so -1. That answer is -3. Graphically here, I'm going to do 2 times. Let's approach 0 here. As I approach 0, looks like about 2.5. We'll say 2.5. Minus 3 times. For g of x, we'll approach 0. And it looks like you're approaching -2. So if you work that through, we get 5 plus 6 is 11. Look at letter C. look at g of x as it approaches 2. Well, as g of x approaches 2 from the right, I have 0. As I approach, or as I approach from the left, I have 0. As I approach from the right, it does this barcode thing, and so it does not exist from the right. So if it does not exist from the right, does not exist from the left, I have does not exist. Divided by, it doesn't matter what f of x is. If one of them is does not exist, the entire limit, in fact, does not exist. So this was a little bit different. Limit as x goes to 5, and we're focusing on f of x. Well, for 5, we've got 4 and 4. So I have 2x squared times 4. What do you plug in for x? Well, x is approaching 5, so you plug in 5. 2 times 5 squared times 4. So I have 2 times 25 times 4, and so that will give me 200. So there's some graphical examples. Now let's do some algebraic examples. It's always great to plug in a limit if you can. Direct substitution works in most situations. That's a quartic function. If we plug in 1, we get 1 minus 3 plus 1, and that is negative 1. It's a polynomial, very nice behaving function, so we could just plug it in. Here we plug in 0. We get the cubed root of 0 minus 27, or the cubed root of negative 27, which is negative 3. This one, we plug in 3, and we get 9 minus 9 divided by 3 minus 3, or 0 over 0. That's a problem. So we're going to do some tricky mathematics. Limit as x approaches 3 of x plus 3 times x minus 3, I just factored the top, divided by x minus 3. So that discontinuity divides out, and you can simply plug 3 in now to what remains. 3 plus 3 is 6. So this discussion came up in class the other day. We talked about it. Since it divides off, what that means is that there's actually a hole in this graph. The hole exists at 3, 6. So this is what the graph looks like. That's what we just did, okay? Now, if you think of it graphically, the limit from the left is 6. The limit from the right is 6, so therefore it's 6. It is discontinuous, or it has a hole at 3. It has a hole at 3. And you notice that the x minus 3 is what divided out. So just take what's left over, that x plus 3, and plug the 3 in, and that'll give you the answer. Plug in 0 here, you get 0 minus 0 over 0 minus 0, which is 0 over 0, and we don't know what that is. So just go ahead and try some factoring. X times x minus 5 divided by x times 1 minus 4x. Now in this situation, you can see that the x's cancel. Try plugging in your 0 now. You get negative 5 divided by 1, which is negative 5. Here you plug in 0, you get negative 2 squared, which is 4 minus 4 over 0, so we get 0 over 0. That's no good. So maybe we actually try multiplying that out. We get h squared minus 2h plus 4 minus 4 over h. Limit as h goes to 0. Notice what happens to the 4's. When as h goes 0, h squared minus 2h over h. Now notice that you can factor out an h. Limit as h goes to 0 of h times h minus 2 all over h, gone. Plug that 0 in right there, and we get negative 2. So in that case, 0 divided by 0 is negative 2. This one, you plug in 0, you get 1 minus 1 over 0, which is 0 over 0. So let's cube out h plus 1. That would be h plus 1 times h plus 1 times h plus 1. You get h cubed plus 3h squared plus 3h plus 1. Notice that these cancel and an h will divide off. So you get limit as h goes to 0 of h squared plus 3h plus 3, because the h divides off. Now if you plug in 0, you get 3. I'm going to do some tricky mathematics here. In this situation, you plug in 1, and again, you get 0 over 0. I'm going to do some factoring. The top actually factors. If you had 1 minus x squared, that would factor to 1 minus x times 1 plus x. Okay? That's how that would factor. But in this situation, when we go to factor that, we don't have an x squared. You just have an x up top. Well, I'm still going to handle this. 1 minus x. Whoops, sorry. 1 minus something and 1 plus something. Limit as x goes to 1. At the bottom we'll have 1 minus the root of x. Well, all we need to know is what do you multiply to get x? Like if it was x squared, you would put x and x. But since it's x, we put the square root of x and the square root of x. Because the square root of x times the square root of x is x. Notice what happens. These cancel. So you have the limit as x goes to 1 of 1 plus the root of x. Plug in your 1 and you get dos, which is Spanish for 2. If you plug in 0, you get the square root of 9 minus 3 over 0, which ends up being 0 over 0. So what to do? In this situation, there's going to be a unique trick that we can do. And the idea is that we want to free up that h that's sitting underneath the radical so it can cancel out with the h on the bottom. So what we're going to do is we're going to multiply by the reciprocal. I'm sorry, multiply by the conjugate. H plus 9 plus 3 over square root of h plus 9 plus 3. Multiplying by the conjugate is a very useful piece in this situation. Multiply the top, we get h plus 9. The middles will cancel, get a minus 9 over h times the quantity. Now be careful in the denominator. You have that h times the square root of h plus 9 plus 3. 9 minus 9 goes away. H divided by the h creates 1 in the numerator. So you have the limit as h goes to 0 of 1 over the square root of h plus 9 plus 3. Plug in 0 now. You get 1 over the square root of 9 plus 3, or 1 over 6. That's the limit. We're going to skip letter I, but we are going to go to J. And in J, there's no factoring that you can really do. It's kind of tough. In fact, in order to handle a limit like this, sometimes you can't do the work algebraically, and you need to go to your calculator. The way we get absolute values in our calculator is we go ahead and we go, catalog is one way, so second catalog. Catalog is the 0 symbol after you press second, and I press ABS for absolute, and x plus 5. I'm going to divide that by parentheses x plus 5. And what I'm going to do now is I'm going to zoom 6 into a standard window so we can see what this looks like. And sure enough, you can tell that if you were to plug in -5, you would get 0 over 0. This thing has a break in it at -5. 1, 2, 3, 4, 5. And it goes down to -1 and up to +1. So the graph actually looks like this. -5, what's the limit of the function? Well, from the left, the limit is -1. From the right, the limit is +1. And since those are different, this limit, in fact, does not exist. There's an algebraic way we can make this argument, but generally speaking, people really struggle with that, so we're not going to focus on that too much. It's really not that important, but I do want you to understand that function because it does come up quite often. There you go. You have enough in front of you to be able to get your work going. Hope you have a great weekend. We'll see you guys on Monday or Tuesday.